So, with NASA's Artemis program, we are heading back to the moon. We're going there to explore, to build, and really to learn how to live on another world. But, to do any of that, astronauts need one piece of equipment more than anything else, the spacesuit. And we're going to break down why this isn't just a piece of clothing. It is literally the single most important tool for survival in the most hostile environment you can possibly imagine.
And here it is. This is what the next generation of moonwalkers is going to be wearing. This is the Axiom xEMU spacesuit. I mean, it's sleek, it's advanced, and it is packed with all kinds of new tech. But let's be crystal clear, this is so much more than a suit. For the person inside, this is a custom-fit, human-shaped spacecraft. It provides absolutely everything they need to stay alive.
And that's absolutely crucial because, well, the moon is trying to kill you. It's a total vacuum with no air. It's being bombarded by radiation, and the temperatures, they swing wildly. Oh, and its entire surface is covered in a layer of fine, sharp dust that is totally alien to anything we have here on Earth. This is the brutal environment this personal spacecraft has to defeat. Now, to really understand the incredible engineering that's gone into these new suits, we first have to look back. On the left, you've got the iconic Apollo suit that took those first steps on the moon. And on the right, you see the workhorse xEMU, the suit used for decades on the Space Shuttle and the International Space Station. Every lesson we learned from these two designs directly shaped the future.
So what were those big lessons? What were the biggest challenges that popped up during those historic first moonwalks? Well, the first, and maybe the most stubborn problem, came from the ground itself.
The reason lunar dust is so nasty is actually pretty fascinating. See, here on Earth, wind and water are constantly tumbling particles around for billions of years, which smooths out all their edges. The moon has no weather, none. So every single grain of dust is as sharp and jagged as the day a micrometeorite blasted it from a rock.
Just think about that for a second. Microscopic daggers. During the Apollo missions, this dust got into everything. It scratched up the helmet visors, it clogged up mechanisms, and it literally wore down the outer layers of the suits. It was this relentless, abrasive enemy, and figuring out how to deal with it became a huge priority for Artemis.
Okay, so you've got this razor-sharp dust everywhere. The next giant problem for engineers to solve, the absolutely insane temperature swings.
When you're in the sun, the lunar surface can get way hotter than boiling water. But the second you step into a shadow, it plummets to temperatures that make Antarctica look like a tropical paradise. The Artemis suits have to protect an astronaut from a nearly 550-degree Fahrenheit temperature range. It's just wild.
And this diagram really shows you what an engineering puzzle this is. The suit has to do two completely opposite things at the same time. It has to act like a refrigerator, venting the astronauts' own body heat out into space to keep them cool. But it also has to be a perfect thermos, insulating them from the lethal temperatures just on the other side of the fabric.
But here's the crucial point. Just surviving isn't enough. You're on the moon to be a scientist, a geologist, an explorer. The Apollo suits were incredibly stiff. Just bending your knees or your arms was a serious workout, which is exactly why the astronauts developed that famous bunny hop. For Artemis, mobility is everything if you want to get real work done.
So how are today's engineers tackling these decades-old challenges of dust, temperature, and mobility? Well, the answer starts from the ground up. Or maybe I should say from the thread up.
This is what's called a bottom-up approach to creating the suit's outer fabric. You don't just pick a material off the shelf, you literally design it. Engineers carefully test and select individual fibers. Then they figure out how to weave those fibers into yarns, and then finally how to construct a textile that can actually survive on the moon. The end result is this complex sandwich of materials, where every single layer has a very specific job. You've got high-strength fibers like Kevlar to protect against tearing. You've got multiple wafer-thin layers of mylar that act as insulation. And then you have a urethane-coated bladder on the inside that actually holds in the breathable air. It's a multi-layered shield against the vacuum of space. And this right here is a massive leap forward in mobility. This is a hybrid segmented joint. So instead of one bulky, stiff layer, it uses multiple components with low-friction slip layers, like Teflon, in between them. This lets the joint bend and twist with way less effort, giving the astronaut the freedom to actually kneel, squat, and reach with ease. It's a total game changer.
So we've seen the incredible technology, but there's another revolution happening that's just as big, and it's all about how these incredible suits are being created. Yeah, who is making this stuff? The answer isn't just NASA anymore. The agency is pioneering a whole new way of doing business that's really opening up the final frontier.
NASA has totally shifted its strategy.
So they spent years developing a reference design called the xEMU, which basically proved a next-gen suit was possible. But now, they've turned that knowledge over to private industry. Companies like Axiom Space and Collins Aerospace are taking that foundation, investing their own money, and competing to provide spacesuits as a service. NASA gets to be the customer.
And, this new approach leads to some fascinating collaborations. One of the most surprising partners? Prada. Yes, that product. Axiom Space teamed up with the luxury fashion house, not for style, but for their deep expertise in advanced materials and complex manufacturing. Their knowledge of how fabrics bend, wear, and interact is priceless for creating a more mobile, durable suit. It's a perfect example of bringing the best ideas from every industry to solve the challenges of space exploration.
And this whole commercial model is just speeding up innovation. The new Axiom U-suit has a rear entry hatch, so astronauts can just slide in from the back. It's got CO2 scrubbers that can be regenerated, which means longer spacewalks. And it's equipped with HD cameras and advanced visors, all while being designed to fit a much, much wider range of body types.
And it is so important to remember, all of this incredible work isn't just about going back to the moon. It's about getting ready for the next giant leap.
The Artemis program has always been about Moon to Mars. Everything we do and everything we learn on the moon is preparation for the very first human missions to the Red Planet.
The moon is where we're going to perfect these technologies. It's where we'll finally master how to fight that abrasive dust, improve how we move on a planetary surface, and test life support systems for long missions. Every single hour spent working in these suits on the moon is critical data for designing the suits that will one day walk on Mars.
From the stiff fabric of Apollo to the mobile, commercially built suits of Artemis, the spacesuit has been constantly evolving. It is still the world's smallest, most essential spacecraft. And as we start to push farther out into the solar system, one has to wonder, what will the next generation of these personal spacecraft look like? What will they become?